LeetCode150 maximum subarray. In this problem, we are given an input integer array and we need to find a subarray with the largest sum and to return this largest sum. What is a subarray? A subarray is a contiguous non-empty sequence of elements within the array. So it's contiguous. We cannot select 1, 4, and 1. We have to select all the items in between. So we see that we need to scan this array, and I'm just going to explain immediately the solution without writing it in order to save time. So because we need to find a subarray, a contiguous subarray, then we can think that we should always have two pointers, right and left, because you see this is a contiguous subarray. We see the right pointer is pointing to here, the right pointer is pointing to here. So as long as the current sum, as long as the current sum is larger than 0, then let's just add items to the right. But if the current sum is smaller than 0, then let's keep it, because it's only reducing the largest sum that we currently have. So we are going to track the current sum that we have. We are going to track a left and the right pointer. Okay, all of them are starting from 0. The current sum is initially 0. The left and right pointers are pointing to the first item. And our max sum is going to be minus infinity. Why do we start with max sum minus infinity and not 0? The reason for this is, if let's say that we had only a single item in the input array, the single item would be minus 2. So we would then ask the maximum in between the current sum, which is minus 2. The current sum at this point would be minus 2. And the maximum. The maximum would be 0. So we would return 0. But 0 was not even in the array. So we start with minus infinity. Anything we find in the array, be it a negative number, positive number, everything should be in our universe larger than minus infinity. Okay, so we have initialized the pointers. We said that we suspect that with the left and the right pointer we can solve this question. We start scanning the right pointer. The right pointer will go from 0 to the length of numbers. The range function knows to handle this and to scan until the last item minus 1. So now we faced an item, we add it to the sum. Everything we face on the right pointer, we just add it immediately to the sum. So we have an external loop, we see here, right? We have an external loop of right, and the right is just going over the numbers, adding them to the current sum, and checking if we passed the maximum so far. If we passed the maximum so far, let's update the maximum. But what if the current subarray that we point to is smaller than 0? If the current subarray that we are currently pointing to is smaller than 0, then it would only reduce the max sum once we add the right item, right? If the current subarray is minus 1, let's say the current subarray is minus 2, and now we move the right pointer to here. So it's 1 plus minus 2. We don't want this minus 2, right? So as long as the current sum, even here, minus 2, minus 3, minus 5, minus 4, we don't want to take this into account, except for the initial max sum. Once we have this, let's move the left pointer to here, because this would only reduce, right? Minus is reducing only from current sum. So this is what we're saying here. As long as the current sum is smaller than 0, and left is less or equal than right, then move the left to the right, I don't want this. I want the left to be here. Once right reaches 4, then I want left to be here. Now there is this little nitpick. Why do we have less or equal? then right, and not just while left is smaller than right without equal. Because let's look again at at this point, right? If I will only move the left to the right as long as left is less than right, then at this point, what do I want? I want both left, because at this point you see all this subarray is total of -4, so we want to get rid of it. So if I would get rid of it while the left is only smaller than right, then when I finish this iteration, then the left would not point both to the 4. I want to finish this, and I want both the left and the right to point to 4, right? This is the explanation why smaller equal and not just smaller. These are the kind of things. Because if the current number is negative, let's say that the current number is negative, okay, we are here, the current number is negative, let's say both left and right are pointing to it. Okay, let's say this is my subarray now, both left and right are pointing to it. So we do want to move the left, right? Left is not smaller than right here when we point to -3. Left is not smaller, it's equal. The current sum, because this is our subarray, only -3, the current sum is smaller than 0. And I still want to move the left to the right. So the left would be here, the right would be still in -3, but because we have this range function, then after the external loop, the right would also get to 4. Okay, so this is handling this edge case, where both the left and the right are pointing to the same negative number, and I want the left to move to here, and then in the range, the left will also move to number 4. Okay, let's go over this quickly again. Max subarray, we want to find the maximum sum of a subarray, which is a contiguous subarray. We are going to have an internal loop and a loop on the right. Okay, we are just going to scan the array, and for that we use standard Python range function. Each time we go for a new item on the right, we add it to the current sum. We calculate the max sum with the max function, and now we say if the current subarray, the current sum that we have is smaller than 0, then it's not adding anything to the sum, right? And as long as left less or equal than right, then in this case we want to get rid of this subarray. This subarray is only reducing items, it's only making it negative. So remove the current left and move the left forward. When we finish this, we know we either left and right point to the same current item that we have, be it minus, be it plus, be it whatever. And when we finish this, if there is a positive number next, we start from the positive number. So this was LeetCode 53 maximum subarray.